Hey, differential equations. As I said, we're going to be doing Laplace transforms, and I broke this up into 2 lessons. And so first we talked about how do you use the Laplace transform in order to convert one equation into another. Now we're going to talk about, well, how do you actually solve an equation this way? And there are 3 keys you have to have. And that is, what is the Laplace transform for a function in general, what's the Laplace transform for its derivative in general, and what's the Laplace transform for the second derivative in general. And we're going to use those 3 keys in order to be able to solve these second order linear differential equations. Okay, now that you've gotten some practice converting terms into Laplace transforms and going backwards, converting Laplace transforms back into their terms, now let's go ahead and use those in order to solve some differential equations. So here's our strategy. Our strategy is to take the transform of each term of the differential equation using these keys. The original function, we'll just change it into s, realize that we've got a capital Y here showing it's the transform. The transform of the derivative is s times the transform of s minus my initial condition. The transform of the second derivative is s squared times my transform minus s times my initial condition minus my initial condition there. One thing to note is these 2 are on your formula sheet as number 35, and this one is number 36. So if you have your table of Laplace transforms, then those are given for you in slightly different notation, but definitely given to you. Once you've done that, then substitute in your initial conditions, solve for capital Y sub s, not sub s, capital Y of s, and then take the inverse transform of each term. Let's go ahead and try that. So let's do an example. So my example is y prime minus y equals 2 cosine 5t. Okay, so this is just a first order differential equation, but let's start a little bit simpler and then we can get more complicated as we need to. So we also need an initial condition. Let's go ahead and let y of 0 equal 0. So then using my keys, we said that y prime was s times capital Y of s minus the initial condition. And then y is just going to be y of s. And so then we've got to take the Laplace transform of 2 cosine of 5t. Okay, so let's figure out what that one is. Looking at my table, 2 cosine 5t, well, we know that the 2 can come out because it's just a coefficient, and then cosine of 5t would be s over s squared plus a squared. A is 5 in this case, so if we square it, it becomes 25. So this over here is going to be 2s over s squared plus 25. Okay, so then the next part is I'm going to pull my 2 s's together. So I've got capital S and I've got a s minus 1 minus, y sub 0 equals 2s over s squared plus 25. We said that y of 0 is 0, so we can take this term and say this goes to 0, or this is 0. And then we have to solve for this y of s. So we have y of s is going to be 2s now two things in the denominator, my s squared plus 25 and my s minus 1. Okay, well, now we have to do the inverse transform of each. But if you look at our table, there's no factors in any of these. And so we're going to have to break these apart. We're going to have to break these apart by partial fraction decomposition. Fraction decomp. Okay, so if we remember how to do that from Calc 2, it says that I can create this into two fractions. One fraction is going to have the denominator of an s squared plus 25, and then the other fraction is going to have the denominator of an s minus 1. Because this is a squared power, that means on top we have to have not only a constant, but a constant times s, and then because this one is just a single power, then that one's just going to be c. Okay, let's go off to the side and do this. So we get a s times s minus 1. No, let's do that slightly differently. Let's do a s plus b times s minus 1 plus c times s squared plus 25. Distributing this in, we get a s squared plus bs plus negative as minus b plus cs squared plus 25c. Combining together my s squareds, s squared is a plus c. Combining together my s's, I've got b minus a. And combining together my constants, I've got 25c minus b. And that needs to equal 2s. Woo. So now I've got a plus c equals 0. I've got b minus a equals 2. And I've got 25c minus b to be 0. So c is negative a, b is 2 minus a, 2 plus a. So plugging those in, I've got 25 times negative a minus 2 plus a equals 0. Okay, so I've got a negative 25a minus 2 minus a equals 0, or a negative 26a equals 2. A is a negative 1/13, or 2 over 26, negative 1/13. That means that C has to be a positive 1/13, and B has to be 2 plus a negative 1/13 would be what? Well, two of them would be 26. So if I subtract one of them, that would be 25 over 26. All right, okay. So that means, going back now to my problem, that y of s is a was a negative 1/13 s, and b is 25/13 over s squared plus 25, and then c was 1/13 s minus 1. Whew. Now again, those are closer. Let's take a look at our table. Looking at our table, I can rewrite these slightly because they all have the denominator of 13. I can pull out that denominator of 13, and we have, nice, we have s plus 25 over s squared plus 25. Unfortunately, those don't cancel out. Ooh, one's negative. That one's negative. Plus 1/13 over 1 plus s minus 1. Okay, let's take a look at these. So looking at our chart, this one isn't too bad. That's going to be number 2. But this one, I don't have an s plus something, do I? No, not really, but I can break this one into 2 fractions. And so I've got now a negative s over s squared plus 25, and I can also break that into 1/13 25 over s squared plus 25 plus my 1/13 1 over s plus 1. So again, this is number 2. Looking at my tables, I can say this one is going to be number 8. And this one, that's 25. So I can pull that 25, pretty much over to here. And so if I'm looking for s squared over 25, or a number over 25, the closest is number 7, but I have to take 5 of these and keep it here. So what I'm going to have to do is I'm going to have to take some of it and leave it here and put it here, and then leave the other half here in order to be the A, to be the top of formula number 7. And so when I do that and do my inverse transform, so now when I inverse all of these, inverse, squared, (1/13) plus 1. Okay, so when I do the inverse, looking at 18, that tells me that this one is going to be a cosine. This one is going to be the sine of 5t, and this one's going to be an e to the t. And there's my answer.